Hi there and welcome back to part 7 of our tutorial series about creating the classic game Pong in Unity. Today we'll have a look at one last bit of a gameplay change, and that is changing the ball's angle whenever it hits a paddle, so to make the gameplay more interesting. And after that, we are working on distributing our game. So we're going to make a build of our game, actually two builds, a Windows build and a WebGL build. And we are going to upload them to itch.io so that we can publish the game and share it with the world. If you are new to this series, I highly recommend starting at the beginning, at part 1. I made a playlist of all the videos in the series so far, and I'm gonna leave the link in the description, and you can also, of course, find it on my channel. And these previous parts, they cover all things concerning game development for beginners. And yeah, so before diving into this, because they are building on top of each other, I highly recommend checking out the previous parts. But if you want to dive into this one head first, we got a GitHub repository, and I'm also going to link it in the description. And you can check out the state of the project after each video. So I'm creating a tag after each video, and you can check out exactly this state on GitHub. One last thing before we get started. Since the last part, I upgraded my Unity version again, and this time significantly. So last time we were still on 2020.3, and now we are on the latest LTS version, long-term support version, which is the recommended version to use, 2021.3. And this upgrade has proved to be pretty stable. I've seen no problems whatsoever, and you can still follow along with 2020.3, or you can upgrade via the Unity Hub and just go to Installs and Install Editor, and there you can find the latest LTS version. Alright, let's dive into changing the ball angle, and for that let's just check out the current state of the game and see why we want to do this. So hit play in the editor and start the game, and right now we give the ball a random angle at the beginning of each round, and it never changes. It always stays the same angle, and it's all right, I guess, but it's a bit boring, and we also want to learn some more stuff. So we're gonna make the gameplay interesting and learn a bit about debugging and some rotational math. One option to achieve this without going into code at all is to change the collider shapes, so the physical shapes of our ball and paddles. So right now they both have a box collider 2D, which is just a box. You can see it with this green line right here. And if we disable this, we can, for example, let's type in collider 2D, and then we have some options here. So maybe let's try a circle collider, and now you can see there's a circle right here. And for the paddles, we can also do this, but we should probably do it on the prefab, right? So that it affects both paddles. So let's focus the paddle right here. Right now, like, this is not so greatly visible, but we can turn off the box collider and add, for example, a capsule collider, so that the edges are slightly round, something like this. Yeah, let's try that out and see how it feels. So we'll start the game, and okay, not much is happening because the only change we can see is when we hit like the ball at the edge of the paddle, and I have to manage to do this first. So okay, so now we saw the angle change, yeah? And that was pretty cool already, but okay, it's really hard to do. But I can tell you, it's not enough for me. So most of the time the angle still stays the same. So maybe let's try something else. We could try to change the physical shape, so the collider shape of the paddles, to something that is more like a triangle maybe. So let's open the prefab again. Let's click the little dots, remove the capsule collider component, and click add component. By the way, my image is in front of this, so it's at the bottom of the inspector, add component. and then add a polygon collider to D. So this is a collider that consists of points. And right now it looks exactly like our box collider previously because it has 4 points. So I'm gonna expand these points here, and right now my image is again in front of it. I'm just gonna make this a little wider, but you can, how do I do this? So maybe let's add just another component. So this one is below, and we can see these polygon collider points above. So, okay, you can see the local positions of these points. And now what we can do is we can change the amount of points to say 3, and now we got a triangle shape. So let's turn off this capsule collider that is just here to move the polygon collider further up. So we got a triangular shape now, which is pretty cool. Right now, if the ball would hit the paddle, it would bounce off to the top all the time. We can press this button here, Edit Collider, and then we can drag around these points. And I think if we hit Control, yeah, they're going in little increments, which is really handy. So we can position this one right here, maybe, and this one maybe in the middle. So we're gonna do a triangular shape, but have it a little bit on the right side. And yeah, let's see how that one works. And first, let's see the paddle on the right, if it worked, because the paddle on the right, yeah, we did this in prefab mode. So now the paddle on the right also has this polygon collider to the right. So we have to be outside of prefab mode and change this one and move this point to the left so that we have the right collider here. And now let's try what this does. Okay, so it does change the angle quite a bit. So we can see this, but I'm not sure if I'm completely happy with it, but it's pretty cool already. Like this is actually where we want to go, but it's still a bit extreme maybe in some cases, but you could totally go with this. So this already feels much more dynamic, so we can maybe try to create a big angle. Yes, so if we go like this, we can increase the angle, and we can also take angle of it. So this is pretty cool. You could totally roll with this, but we're gonna explore another option. First, let's set our colliders back to box colliders, because we don't need them to be like fancy circle or polygon colliders for what we are going to do next, because we're gonna work some code magic. So on the ball, re-enable the box collider to D and remove the circle collider. And on the paddles, open them in prefab mode and just enable the box collider again, remove the polygon collider, and remove this capsule collider that we just added so that you can see the polygon collider better. Let's go into our ball script and create a new method right here at the almost bottom, and this is called adjust angle. And as parameters, we're gonna pass a paddle and the collision to D, and we're gonna call this whenever we hit the paddle, which is right here. So here we're going to call adjust angle and just give it the paddle that we hit and also the collision that we get up here from the onCollision enter to D method. So let's quickly think about what we actually want to achieve. So we got a box hitting a box, and we want to give it a different angle depending on where it hit. And I think it's probably a good approach to give it like a flat angle if it hits towards the center, and a more steep angle if it hits towards the edge of the paddle. So maybe we can just, as we define this as our goal, make a comment here so we can remember what we actually want to do. To determine how far the ball is away from the center of the paddle, we need its relative Y position to the paddle's Y position. And we could just use the ball's Y position for this, sure, why not? But we want to learn something, so let's try something fancier, and it looks a little bit like this. A collision 2D and 3D collisions also, they have a list of contact points. Most often there's just one contact point, but we got a collision of box on box here, and in this case it is usually 2 contact points if both boxes are upright. So we're gonna visualize this in a moment, but just let me explain this code. So we want to have the point between these collision points, so the median point of the whole collision. So we're going to define this median as a vector 2.0, and then we're going to go through all the contacts of the collision. This is collision.contacts, and we're going to add their position, aka point, to the median, and after that we're going to divide the median by the contact count, and like this we can get, yeah, like it says, the median point of all the collision points. That sounds a bit abstract, so let's visualize it. And for this we're also going to learn something new, and that is the debug draw array method. It draws a line inside our Unity editor for us to help visualize stuff and debug stuff. So you're just going to type debug draw array, and then it takes an origin. This is the start point of the line. Then it takes a direction, which in this case we're just going to take vector3.right. We can add a custom color to it, so let's do it, and we're going to take the color red. And then this is important. Usually if you call debug draw array, it only draws for 1 frame, and this is pretty hard to see if you actually want to see these rays. So you can give it a duration, and we're gonna give it a duration of 1 second, so we can see the lines for 1 second. Let's see if this is enough. And let's also draw the median point. So up here in this for each method, we're gonna draw the 2 contact points, and here we're gonna draw the median point, and let's draw it in a different color. And now when we get back to the editor, and let's focus on our pedal and inside the scene view. You can see this inside the scene view. Let's start the game. And okay, so this is, yeah. Oh, you already saw it, maybe? Yeah, okay, you see these lines, but they are disappearing quickly. So, and also the ball is going off quite quickly. So would be cool if we had like a way to make it stop. Oh, we do have that way. So the way to do this is by using debug.break, and this is exactly the same as if we would press this pause button in the editor up here. You will see this in a second. So let's start the game and check it out. And once the pedal has been hit, you see this button light up, and also the game pauses. So that's exactly what we want, so we can check out what is exactly happening here. So now we see those lines clearly in relation to the ball. So these 2 red lines, they are the contact points, the upper and the lower one of the box. And this line in the middle is our median point that we calculated, and you can see it's pretty much in the middle of the box. One more remark about this. You see that our box, our ball, is not exactly lined up in the moment of the collision with the pedal. The reason for this is like something more advanced. I'm just gonna scratch the surface here, but drawing onto the screen, aka each frame, aka the update method, is running on a different timer than physics calculations, aka the fixed update method, if you already heard of that. And that is why this collision has already happened or is happening in the next frame. But we have, like, we can go 1 frame to the next. Okay, so this collision has already happened. By the way, this button is super handy. Like in pause mode, you can go frame by frame through your logic and through your game and see what happens each frame. This is so cool. But yeah, like I said, maybe we can check out another collision. So let's have the AI collide and focus on the ball. Yeah, this time we are even further apart from this already. So the collision has happened already, I think. Yeah, it has happened already before this frame has been drawn. And this box has already moved away a little bit from the pedal. So yeah, this is a bit of a more advanced topic, and we don't have to really go deep into this here because this works more than well enough for us. But I just want to hint you in the direction. If you ever get problems in the future with physics, I encourage you to check out like the rigid body's collision detection mode. Like for moving objects, you should use continuous. And you can also play around with this interpolation variable. And we, of course, also still have the project settings. Like remember when we fixed a physics problems with the bouncing off by changing the velocity threshold? Well, there's a lot more stuff you can do here. And yeah, there are some specific physics problems that you can only solve by going into here. And I hope you don't run into them like ever, but if you do, you can often just Google your specific problem and you often find a good answer on the Unity forums. And if you don't find one, you can open a thread yourself. Let's continue calculating our ball's angle. And for this, we go back into the ball script. And for now, we're going to remove the debug break. We're going to add it again later if we need to, and use this code. For these mathy calculations, I always encourage you to write a comment explaining what is actually happening. Because if you look at this code 1 week or 1 month or 1 year from now, these comments help tremendously. Like for everything that is not immediately clear, I encourage you to write a comment to your future self or to future team members to let them know what's going on. And what's going on here is that we calculate the relative distance from the center between -1 and 1. We want to have it between -1 and 1 so that we can easily multiply it with a max angle that we're going to add in a moment. So first we're going to calculate the absolute distance from the center, and this is just the difference between the median's y position and the pedal's y position, which is in the center of the pedal. And then we're going to calculate the relative distance from the center. And for this, we're going to divide the absolute distance from the center by the pedal's local scale y, so that we have it in relation to the pedal's height. And we still got to multiply it by 2, because otherwise it would be between -0.5 and 0.5. You could also work with this, but I like having values between -1 and 1. And this code right here, where we get the pedal height, this is a bit suboptimal because the ball shouldn't actually know how the pedal's height is defined. The pedal itself should know this. So let's add a method to our pedal, which is called getHeight, and we return just the transform local scale.y. And if the height is determined by something else, if we change something later on, we might. And then we can easily change this method right here, and we don't have to fiddle in the ball script. So this is something that really concerns the pedal and not the ball. So let's go back into the ball and let's change this call to getHeight. And this is much better, like software architecture wise. Now for our next calculations, we need to know if the pedal we hit is the left or the right pedal, because it bounces off in a different direction. And so far how we did this is by comparing the ID of the pedals. So ID1 is the left pedal, ID2 is the right pedal. We're doing this right here, and we're doing it right here. We're doing it in multiple places, and we're going to do it in another place. So let's create a method for this. Is left pedal, and it returns ID equals 1. In the next video, in the last one, we're going to do a little bit of cleanup for the code, and then we're going to clean up this code concerning this method. You can do it in the meantime if you want to, like using this method instead of this right here and this right here, but I'm going to leave this for you, and we're going to go to it in the last video. So now we can use this method in our ball script. Next up, we'll calculate the angle at which our ball bounces off. And for this, we use a type called quaternions. First of all, we're gonna use our newly created isLeftPaddle method to determine the sign of the angle. So if we had hit the left paddle and we're going back to the right, then we're going like this, yeah? And if we hit the right paddle and going to the left, then we're going like this. So we have to calculate the angle by 1 or -1, depending on which paddle we hit. And now this quaternion, I'm not going to go into details on this. This is a big topic in and of itself, but quaternions, you can hover over it. They are used to represent rotations, and rotations are a fiddly thing because you are rotating around like 360 degrees and then it starts again at 0 and stuff like that. This is something complicated, and I encourage you to check out maybe some math tutorials on this. This is way beyond the scope of this tutorial here, but just know they help us with rotations, quaternions. And in this case, we're going to use the angle axis method. And the angle axis method, like it says here, creates a rotation which rotates angle degrees around an axis. And this axis is the second argument, and you see our line here is really long. We can't even see the rest of it. And usually in this case you do a line break so you can see the second argument, but now it also sometimes it looks awkward. So for our case, maybe it's a good thing to introduce a new variable called angle that is calculated by this term right here. By the way, I'm going to get to the max collision angle in a second. So now we can put the angle in here and have the axis as the second argument, and it's much more readable right now. So let's check out what is this axis. It's vector3.forward. This is the axis that goes into the screen, so it's not even on our 2D surface anymore. But this axis, if we rotate around it, so you got my finger right here, if we rotate around this axis, then it goes like this, yeah? And this is exactly the angle we want in the plane we wanted, in the 2D plane. Now let's introduce this new variable max collision angle at the top. So we're just gonna, let's put it below max initial angle, and let's set it at 45 degrees. So our max initial angle is between 0 and 1, and our max collision angle is in degrees, so it's between 0 and 360, just to explain this. And now let's explain this angle. So we have this relative distance from the center, which is between -1 at the bottom and 1 at the top. And we're gonna multiply this with the max collision angle with 45 degrees. So at the top, it's gonna go all the way 45 degrees. In the center, it's gonna be 0 because the relative distance to the center is 0. So it's gonna go just to the right or to the left if we hit the other paddle. And in between, it's gonna grow like step by step, just like we wanted. And also to the bottom. And we also have to multiply in this angle sign to account for the left and the right paddle. So now, finally, after all this preparation, we're gonna calculate the final velocity of our ball, and we're gonna do it like this. So first of all, we need a direction, and if it's the left paddle, we're going to the right, and if it's the right paddle, we're going back to the left. Then we calculate the velocity. And for this, we take the rotation and just multiply it by the direction. And then we take the previous velocity's magnitude, which is the speed of the ball, so we can maintain the speed of the ball when we reflect it. And then we just set the velocity, which we just calculated, to be the rigid body 2D's new reflected and angled velocity. And we're also gonna debug draw a little ray to visualize this. So now the moment of truth is here. Let's check this out and make sure to have like the whole field in the scene view so that we can see our debug lines. Let's check out these debug lines first. Okay, so we got this green line and it goes exactly in the direction of the angle where the ball is going, okay? And you can already see like this angle is changing dramatically depending on where I hit it. It's always the same from the relative distance, but we can like change this velocity to go down again and stuff like that. And we can also check out, like, remember when I told you that for the quaternion we used axes into the screen? I also drew a ray there, and I can show you, like, let's turn off 2D and let's do it like that. And now when we hit this pedal right here, okay, maybe we need a debug break for this. Okay, so it hit the ball right here. We are now in 3D space, and this is the axis of the quaternion that we used. Yeah, and if we use this axis, like I showed you before, into the screen, then when we go into 2D mode and scroll around here and this axis goes into this, then we rotate like this. So now we can let our AIs play against each other a little bit, and we can, for example, change the max collision angle. Let's make it 10. So we only have very flat angles now. So like even at the tip of the paddle, it's only gonna be 10. So they can play for some time. So we can also change this to 80 to allow for really steep angles at the end of the paddle. And now what you see, yeah, okay. So this is probably a bit much. I really like 45 degrees. I think it plays well, but you can play around with this however you like, and just make it your own. Let's just quickly clean up this debug log right here. We don't need it anymore. This is just for testing purposes. So you can throw in some debug logs and debug draw arrays. So maybe we don't need these anymore. So let's just comment them out. You can also remove them after you're done. So these debug functionalities are really helpful while you're trying to get things working. And once they are working, you can just comment them out or delete them. I like mostly commenting them out, so when a problem occurs, I can comment them back in and check stuff out. So once again, this is just one approach you can go about this, or maybe two. We also showed the approach with the polygon colliders, which was also pretty good. And you can adjust this approach. So this is not the simplest approach. You can go even in code. You can make this simpler in code. But with this approach, you have a lot of power to factor in different things, like maybe the previous angle of the ball. You could factor this in, and it affects the outgoing angle of the ball, which is not the case right now. Or you can factor in the velocity of the paddles, like if it's going currently going upwards, then the ball's angle is slightly more upwards, or something like that. Just try out stuff, see what works best for you, try to learn as much as possible. But for this tutorial, we're gonna tick this off the list. I think this was enough math and debug for now, and we're gonna go to something much easier and smoother now, to the build of the game. Currently, we can only run and play our game inside of the Unity editor. And to change that so that we can run it on, for example, Windows, on Mac, Linux, or in our browser, or maybe someday on consoles, who knows where we might go, not in this tutorial though, we need to make builds of our game. So this is Unity's way of putting the game together so that it can run on the target platform. And to do this, first of all, we're gonna go into the project settings and change a few things. And most of the relevant settings for the build are in the player project settings. You can also bring this up, like if you are going to File, Build Settings, and then here at the bottom left, you see player settings. Here we can change our company name, or just enter your nickname or something like that, whatever you want. The product name, I already named this Unity Pong like way before, but we got a real name for it now, and it's Pong with a lowercase p, so let's do that. And for version, let's say we're releasing already, so it's version 1.0, and you can also add some icons. We're not gonna do that here. There's like icon overrides for different platforms. You can change the resolution and window versus full screen stuff and the splash image and lots of stuff. Like these other settings, these are mostly more advanced stuff. So maybe keep your fingers off these for now, but you will need these later, I guess. Some of them, for example, scripting defined symbols are very helpful. But yeah, we're not gonna go into too much of that. Just set the company name and the product name to whatever you desire, and we're gonna get back to this in a moment. Now, we already have our build settings open here, but if you missed this earlier, let's close this again. You go to File and Build Settings. And I already have this scene added in here. It might look like this for you without this Scenes in Build thing. Just click Add Open Scenes, or alternatively, if you don't have this scene open, maybe you have another scene open, you can just drag and drop the scene from the project view right in here. And now, if you followed this tutorial series along, you should have installed the Windows target platform already. If you're on Mac, I hope, or on Linux, maybe you have installed this target platform. We're going to get to the other target platforms in a second. Just for now, you should have probably, most certainly, Windows already selected. If not, go here and maybe you can choose switch platform, choose Windows here, or if you're on Mac or Linux, Mac or Linux, and then we can click build. And now it prompts us to select a target folder for our build, and it most certainly starts within the Unity project for you. And since for me, this is a Git repository, I don't want to have my builds inside my Git repository. And I encourage you to not do your builds into your project repository, but outside of them. So here we have our Git repository root, and this is the folder for the whole project. And I already created like a folder for the Windows build. I'm just gonna select this, select folder, and Unity is gonna do its thing. Building the game, it's gonna take a moment, and we just have to wait until it is finished. And this shouldn't take too long, and it already opened up a folder containing our game, and now we can just click on pong.exe and start our game. And we're outside of the Unity editor. That's so cool. Do we have music? I just gonna check. Yeah. There's music and sounds, it's all working, so let's just start the game. And now we're playing on Windows without the Unity editor, so our build was a full success. Of course, we haven't added like an exit button or something like this, so I'm just gonna out a 4 out of this. Now, if you also want to build for different target platforms than just Windows, go into the Unity Hub and under Installs and click this little cog icon right here, and you can add modules, and then you can scroll through this. So we have iOS and Linux and Mac, and I already installed Windows like you see here and WebGL. And for you now, I want you to install the WebGL support. So on WebGL, you just click this one and then install, and it's gonna take some time. And after that, you will have to probably restart the Unity editor to continue. So do that now and then continue with the video. After having restarted the editor, go again to File and Build Settings, and then click on WebGL here and on Switch Platform. And this is gonna take a moment. I'm not sure actually how long. Maybe for the first time it takes a little bit longer. Also, in general, builds take longer the first time you do them for a target platform. After that, Unity has some things cached, and then it goes faster. So right now it says cannot build player while editor is importing assets. So it's still rolling. We just didn't see it. So it's now reloading our scripts, and now we have the target platform WebGL selected, and now we can again click on build, and once again navigate to a different folder, and I got one right here, Pong WebGL, select this folder and wait again until the build is finished. And like I said, for the first time it might take a while. This took around 4 minutes for me to finish, and now we got our build in here. And if we now start this index.html in our browser, it opened on my other screen. Wait a second, I'm just gonna drag this one over. It says that it can't do it because, well, we're not running it on a web server, and WebGL games have to run on a web server. So you can run this already if you have like a local web server up and running, like an Apache or something. But we can also do it from Unity by choosing build and run. And Unity, we're going to just select the same directory, by the way, to benefit from shorter build times in consecutive builds. You have to choose the same directory, as far as I know. So don't delete this one, just select it again. And we're just going to wait this one out because this is going to be much faster than the first one. This is a promise, and I hope it's going to get fulfilled. Come on, don't leave me hanging, Unity. Okay, so it already did it, and it again opened on my other screen, but I can drag it over, and as we see, we are now on the local host that Unity started for us. And there's our game, and we can already play it, but we see that the resolution is suboptimal. So let's head back into the editor, and maybe you still got your player settings open. I still have. Otherwise, navigate there, and you can see up here we can change the target platform. So now we're in WebGL settings, but we can also, previously we were under the Windows settings. So now for WebGL, we can actually set a resolution for us, and let's do it because we developed this game in 16:9. Let's choose a nice 16:9 resolution, 720p. I like this one for web games a lot. And then let's build and run it again and see if this fixes our problem. So once again, this is going to take like 10 seconds maybe, and it's probably gonna open on my other screen again, but we're so far in already. We got those few seconds, right? So any moment now, there it is. I'm gonna drag it over, and now we got the correct resolution and we can play our game as it is intended. AI versus AI. That's the intended way to play this game, right? And we also have this little full screen button down here, so we can make it full screen, and we can press ESC to escape to exit full screen. And yeah, we got our WebGL build up and running, and we also had our Windows build up and running, so we got both of our builds up and running and can tick this off the list. Now let's upload our game and share it with the world. And for this, I highly recommend this website right here, itch.io. It's the perfect place to upload your smaller games, even bigger games. Like it's the indie game website for smaller games. There's so many games on here. Like even if you just want to play games, you can go here and play like forever. Lots of free games, a lot of game jam games. So I love itch.io. It's made for small developers like you and me. So first you have to register a new account. I'm not gonna walk through this here. This is a pretty straightforward registration process. Just make sure to tick I am interested in distributing content on itch.io, because that's what we want to do. And after that we can just log in, and I'm gonna log into my account, and it's gonna go to my dashboard. And yours is probably gonna be completely empty because you just created a new account. You got nothing in there yet. So we can, from our dashboard, we can, by clicking our profile name, we can go to our profile page. This one is mine, yours, once again, probably empty. And here you can go to edit profile and just edit stuff, and I highly recommend editing the theme of your page so it looks a little bit more individual and in my case atmospheric. And once you're done with all of that, we're gonna continue to creating our new game. Click the little drop down up in the right corner and choose upload new project. And now we can give it a title, and this title, like here's a lot of stuff that you can fill out about your game, and I'm just gonna quickly walk through it. So the title will also determine the URL, but you can customize this if you want to. So we can add tutorial. I'm just gonna leave it at Pong for now. I think we can probably also change this later, but if you change the URL later and some places in the internet already point to it, you know, that's suboptimal. So let's continue with adding a short description. The classic, reimagined and created for the YouTube tutorial series by me. So this is a game. You can also choose other things like game assets, mods, album soundtracks, comics, books and stuff. The kind of project, this is important. If you choose downloadable here, we will not get the WebGL build to work. So you gotta choose HTML here. This doesn't affect the Windows build though. We can still upload this and people can download it. So for the release status, let's just say it is complete, but you can also choose in development or something else. For the pricing, let's just leave it at $0 or donate. This is just for like for people who play the WebGL build, they are not prompted to pay you anything. But if they want to download the game, there's this little prompt where they can just enter $0 and they don't have to pay for it. So it's a pay what you want. And for the suggested donation, let's just leave it at default. We're gonna get to the uploads and the embed options later. Let's fill in these details first. So here you can describe your game. For example, the controls of your game, you can name them here. That is quite common if you don't have a tutorial in game. We have a tutorial in game, so we don't need to do this here. But yeah, just describe your game, leave some links maybe here. And for the genre, well, since there's no arcade genre, let's pick action. For the tags, maybe here we can do arcade. So these are just the tags. Tags, like let's tag this a little bit. We can also tag it like with Unity, so people can search for games made with Unity. We could also maybe tag it with tutorial. I don't know, just use the tags that you want to use. We could also do AI and stuff like that. Here you could add more links, but we are not on Steam yet, maybe someday in the future. You can also give your game a custom noun. Okay, and so that's it for that, and we can save this page for now. And yeah, okay, it takes us directly to the page, and there was a problem. Of course, we haven't uploaded a build yet, so let's continue with that. Just click on Edit Game to be taken back to the Edit Game page. And since we're up here already, let's make a cover image first and the builds after that. So I think the cover image is mandatory to release the game, and you also want it. Like, we can use a screenshot for this. So let's go in here, and most operating systems have a screenshot tool built in. For example, for Windows, you have to press the Windows, Shift and S key, and this will open it up, and then you can select an area and it's gonna make a screenshot of that, and you can edit this further. Personally, I like using the program GIMP. It's like the indie version of Photoshop, and I'm just gonna show you how to do it in there. Let's use a screenshot from our game. So maybe you change this to play maximize so we have a bigger resolution to work with. Start the game, and then let the AIs play against each other. And then at some point, when it's cool, you press print, the print key. And then we can go out of it and go into GIMP, press Ctrl V, and we got this in here. So now we just want the screenshot and not our whole monitor or multiple monitors like in my case. And I'm just gonna select this area here. which is just the game area. So we're going to select it with the rectangle tool. This is not a GIMP tutorial, by the way. This is just really quickly. And we're going to image, crop to selection. And now we got only this selection, but we need certain dimensions for this. So we need 630 by 500, which we don't have right now. So back inside GIMP, go to Image, Scale Image, and enter the correct height, because I think we're gonna cut it in the width. You can also do this differently, like enter 630 here and then adjust the height. But wait, if we enter 630 for the width here, we gotta add to the height. So that's not so good. We just wanna, like, what are we gonna add? Maybe you can add something you want. Yeah, of course. But it's easier to take something away than to add something. That's probably also game design wisdom, or is it? I don't know. You decide. And okay, it's getting a little bit late already, so let's do this. Okay, let's select this whole image, Control A, and then we can click inside it, and then we can just drag this one over until we're at 630. You can see it down here. We are now at 630. And now once again, we go to Image, Crop to Selection, and feel free to do this completely different. I'm just going to show you one option to do it. And then we can add some text. Like, this is not looking super cool, but okay, let's just add our text. Okay, I want this to be white, definitely. So let's select it, and let's select the color white. Okay. So maybe we can just leave it like this. I don't know. It doesn't really look great, but it looks okay-ish. So now let's go to File, Export As, and let's navigate to our project. And I'm just gonna name this cover 630 by 500. I sometimes like entering the dimensions of an image into the file name itself, because for a lot of websites you need different dimensions of the same image over and over again, like you will probably see in your game dev career at some point. So let's export this and go back into the browser, and now we can just drag this one right here. No, dragging is not good. Let's choose upload cover image, and these are my achievement icons from my game recollection. So hope you like them. Let's go back to game tutorials, Pong, and choose this cover. Okay, that was a bit of a bumpy section, but we got our cover image all set up, and it actually looks all right. Let's go on to the builds of our game. So we go down to the upload section, and we gotta prepare our builds. So open your folder again, that you had, and now we gotta zip our builds. So usually on Windows and on many OSs, this is also built in. Like on Windows, this is the old right-click menu. You can use send to and compressed zipped folder. There's also on Windows 11, there you have this option, like also directly, I think it's called archive or something like that. You can see it. I personally like using 7-zip. You can find it on the internet, and it's a very efficient zip program. And we can just do 7-zip, add to pong winbuild.zip, and it's gonna do it. It's really, really fast and has good file sizes, good compression. So for the Windows build, we can zip the whole folder, but for the WebGL build, we gotta have this index.html at the root of the zip file. So we're going into the folder, selecting everything, right click and zip it. Okay, and now we got our WebGL zip file also. All right, let's upload our builds. Click upload files, and let's just select this Windows build file, and it's gonna upload. And in the meantime, we can already select the next one, the WebGL zip file, and upload this one too. And this is just gonna take a moment to upload. In the meantime, we can go to the embed options, and we embed our WebGL build in the page, and we can auto-detect the size, Unity HTML only. So let's use that one. In the meantime, this one has finished. So we're gonna configure this. Pong Windows build, it's an executable. Okay, and we can tick this one right here. You can also set a different price for this, but for the WebGL build, we gotta tick this one. This file will be played in the browser. Only then can our WebGL build be played in the browser. And yeah, let's save this page. Like, we can scroll down here and save the page, but it's also very handy up here to save the page and view it. And our game doesn't load correctly, damn it. No dimensions provided or detected. Okay, so this is something that I don't exactly know if it's on my part or if it's on the part of Unity. So this auto-detect size, Unity HTML only. I researched this and it seems to be buggy in some versions of Unity. So this might already work for you. But if, like for me, this doesn't work for you, let's get it to work. So we can manually set the size. And here, we're not gonna just enter our 1280 by 720p, but we're gonna add 16 pixels for the width and 60 pixels. So 720 plus 60 is 780, because we have a frame around our game on the itch.io page. You will see this in a second. So let's do this and let's view the page again. So now we can see that it embeds correctly and we can run the game. And you see down here, this Unity, okay, don't look at the arrow for now. You can see these little frames. If you set the dimensions differently, these would look weird. And this full screen button would disappear. Like if we go to 720, you can try that out, then it's gonna cut off a part of this up here and down here. So try this one. But now let's get to the error. So this is already the second problem that we run into with the WebGL build, and this really reflects my experience with WebGL builds. There's often a lot of problems and some hurdles to overcome until they work correctly. For example, sometimes the sound doesn't start or something like that. And then this thing with the dimensions. One thing I have to mention though, which is probably on my part, sometime in the past, you can see in these player options, we got WebGL templates. Sometime in the past, I fiddled with these and created a minimal one without like these Unity icons at the bottom. I'm actually not sure if this minimal one comes by default with Unity. I'm not sure. Maybe you can tell me in the comments. But I have to check this out again, and I'm probably gonna do a tutorial on WebGL builds exclusively sometime in the future and shine some more light on these issues. But for the moment, this is like, we're gonna get this to work. So let's go back to our error now. I could now just show you what you have to change for this error to go away. I could have done this before we even ran into this error. But what I want to show you is how you can deal with stuff like this if you run into it. And usually, when you get an error message, like you select, that's at least how I do it. You select the relevant part. The relevant part is often the error message itself, like check browser console and DevTools network tab to debug. Yeah, that seems a bit much for most people. We could do this, but the easiest way is to just copy this text, Google it, and then see what we can get. And okay, these are different Google results than I got when I Googled this last time. But let's just check out the Unity forum. Okay, so this looks pretty much like our problem. Okay, they're posting their player settings, and here we have one possible solution. Like usually, yeah, you run into an error, you Google it, you go through the Unity forums or Unity answers or Stack Overflow, and you search for these answers, and usually you find your answer within a quite short amount of time. And you have to try some things out. Like sometimes the first answer isn't the correct one. Actually, a lot of times the first answer isn't the correct one, except Stack Overflow and stuff like that, where answers are upvoted. Then mostly this is the correct answer. But let's go changing the compression format to disabled. So it doesn't say where we find this. It is in the player settings. So let's go a little bit further. Under publishing settings, compression format to disabled. I also actually saw, like in my previous research, that we can change the compression format also to gzip. This will also work. I tested this before recording this video. So that was another answer I found on the internet because Google spat out something different. And I think some compression is probably better than no compression because our files will be larger. And if we can avoid that, then we will do this. So now we found this out the old school way. We are Googling, and yeah, I hope you learned something about how to deal with running into errors like these. Now we changed this one setting, and trust me, it's often exactly one setting if you run into issues like these. And now we gotta go through everything again. Build settings, build our WebGL build. It's gonna, of course, not take so long. That is nice, but yeah, still. And we go into the WebGL folder. We delete this old zip. We pack up a new zip. Okay, here it is, Pong WebGL. This is the updated version that has the fix in it. And then we go back to edit project. Maybe we can close all these tabs. We go back to edit project, upload files. We upload this one again. So this is, yeah, this is a little tedious, but this is a big part of game dev actually. Like solving these weird technical issues, like especially last minute, I want to submit to a game jam issue. I only have 1 hour, but it's not working. Okay, I highly encourage you to do a game jam after watching this tutorial because you will learn even more than here, I promise you. And now we saved this one. And now we can go in this and hope it's gonna work now. But we could also run into the next issue, right? But hey, it is starting, and it even has music, so it seems to be working properly. Let's start the game. Yes, this is working. That's great. Cool. We can refresh the page, and we can also, like, we have our download down here. This is our Pong Win build. We can click download now or others. So this is the one that I mentioned earlier with the donation. You can just click no thanks, just take me to the downloads, and it's just one more click for people to skip this donation. So I think it's not a big deal. All right, so we got both of our builds uploaded. That's awesome. Okay, I just noticed another problem. You see this full screen button down here is now gone for me. That's because I accidentally chose this minimal template, which doesn't have it inside. I'm not sure. Please tell me if you have this minimal template in the comments. But you know what? So maybe this is already working for you. Maybe it has worked for you long ago. I'm just going to address these issues. But we can now make this even cooler right here. So let's go back to this project settings and let's make this 720 plus 16. So 736, and let's add a full screen button from here. So we save this, and there's something else I want to do, and that is edit the theme of this project page. So I want the background to be rather black, maybe background 2 also, and the text to be white. So the game stands out more. So we can save this now and close this edit theme button. So yeah, now I think it will look better. So now we got this little full screen button from itch.io down here, and let's check out if this works. And let's start the game. Okay, and this full screen button, it is not working correctly. So I really have to work on my templates. I can't promise it, but I will really try to make a tutorial on this, and I hope everything is working for you. And if it isn't, let me know in the comments and I will find this out for you even before I do the tutorial, okay? Alright, yeah. So, no full screen button then, I guess. So let's just tick this off, save it. Yeah, once again, let me know how it looks for you. So this WebGL stuff has been a bit bumpy, but it is working well enough now, and I think we're ready to publish our game. So all the way down here, you can choose like restricted. Then you can just send it to some people with a password. This is great for testing and stuff, but we're just gonna go public now. Okay, let's just do it, even though this video is not even up yet. So I'm just gonna save it and view this page, and I'm gonna edit this one a little bit more later. But now this thing is public. I'm not actually sure if this fits in with the rest of my games. Not really, but hey, it's now on my itch.io page. So, and if you have this, you can send this URL to everyone you know, and they can play your version of Pong. And you can now go to your profile page, and there it is, Pong. And you can go to your dashboard, and if you send it around, you can see some numbers going up here. Numbers going up, that's always great, right? So yeah, we just published the game. That's pretty amazing. Okay, I think that's it for the upload part of this video, and let's go to the outro now. Congratulations, you just made and published a rather complete game, including stuff like player input, a menu, an AI opponent, visual effects, music and sounds. So much stuff. I really hope you enjoyed this series so far and that you learned a lot. I definitely enjoyed it, and I also learned quite something during my research that I could pass on to you directly. That was pretty cool. So there's gonna be one more video in this series, and it's gonna be about two things. Just like today was about the angle and build/publish. Next time we're gonna first clean up our code a little bit in our project, try to make everything tidy and nice, and then I will give you a little outlook, some ideas on where you could take this game from here, because this is rather complete, but we could go in so many places with this, so I hope you tune in for this one. If you have any feedback or questions concerning this series or my other videos or game development or Unity in general, just leave them in the comments. And if you followed this series up until now and you have finished and published your game, please also leave a comment about this. I want to play your creations and check them out. I think you cannot directly post URLs in the YouTube comments. I think this is not allowed, but you can, for example, post your username. Mine is Erkberg, and then I can use erkberg.itch.io, your username.itch.io, and I can go there and check out your version on Pong and give you feedback on it. So yeah, that's it for today. See you in the next one. It's not gonna be that long of a wait time again. I promise this. This is a holy promise. Like it's been 3 months, I think. So sorry about that, but we're gonna wrap this up very soon and then go on maybe to the next series. We'll see. Have a great rest of the day. I hope you enjoyed this tutorial and this series. See you here again soon, and bye.